Hi everyone, welcome back to Gide Academy. In this video, I'm going to show you how to solve systems of equations using the Cramer's rule. Alright, so the first thing we're going to do is we're going to create a coefficient matrix. So which means here we're going to list the coefficients 2, 1, 1, 1, minus 1, 4, 1, 2, minus 2. Alright, all that equals, sorry, actually before I do that, I'm gonna write here the variables x, y, z, so that this equals to 1 or 3. So these are the answers. Okay, so the first thing we're going to do is we're going to find the determinant of the coefficient matrix. So here I'm just going to do it here. Now to find the determinant, I'm going to take 2 and I will put this mini matrix here. So minus 1, 2, 4, minus 2. Second, I'm going to move to 1. So here I'm going to have minus 1. I'm going to have 1, 1. So here 1, 1, 4, minus 2. 4, minus 2. And next I'm going to have plus 1 and 1, 1 and minus 1 and 2. Minus 1 and 2. Alright, so here we have 2 inside minus 1 times minus 2, positive 2, 2 times 4, 8, so 2 minus 8 is minus 6, minus 1. So again, here inside we have 1 times minus 2 is minus 2, 1 times 4 is 4, so minus 2 minus minus 4 gives us minus 6 again here, plus 1, 1 times 2 is 2, 1 times minus 1 is minus 1, so 2 minus minus 1 will be 3. All that becomes minus 3, so which is our determinant for the coefficient matrix. Alright, so the next step is to rewrite this matrix, but in this case we're going to put the solution here, here, here. So when we want to find x, we're going to put the answer in this one. So what do I mean? So let's say first we're going to find the determinant here. So because I want to find the determinant when for x, I'm going to sub the answer in here. So I'm going to have 1, 0, 3, 1, minus 1, 2, 1, 4, minus 2. Alright, so from here I'm going to find the determinant. So it's going to be 1, minus 1, 2, 4, minus 2, 0, 1, 2, 1, minus 2, plus 3, 1, minus 1, 1, 4. So here please notice that I kept these two columns as is. I only changed the first one because x is my first variable. Alright, so here if we do this again, here we have minus 1 times minus 2, 2 times 4, 8, 2 minus 4 becomes negative 6, so I'm going to have negative 6 here. Now because this is a 0, so whatever comes out of here will be 0, so I don't need to worry about that. So it's 0, so I'm just going to take away 0 from here. I have 1 times 4, which is 4, 1 minus 1 times 1, minus 1, so this is 4 plus 1, which is 5, times that by 3, 15. Now, so minus 6 plus 15 is 9. So therefore, the value of x is, so according to the Cramer's rule, determinant of x divide by the determinant for the coefficient matrix, which is 9, divide by -3, which will be -3. Alright, so now let's do this for y. So for y here, I'm gonna have the same thing, but this time I'm gonna change the middle one. So I'm gonna have 1, 0, 3, 1, 4, -2. Alright, so here I have -1, 1, 1, 4, -2, plus 0, 2, 1, 1, -2, -3, 2, 1, 1, 4. Alright, so again, if we do this, we get -2, take away 4, which is going to be -6. There's a minus here, so it will just become 6. Here I have a 0, that is just going to become 0. What about here? Here I have 8, take away 1, 7, multiply that by -3, -21. All that becomes -18. Okay, so therefore y is, sorry, here I made a mistake. 6 minus 21 is actually -15, it's not 18. So I should correct that, it's actually 15. So -15 divide by my determinant for the coefficient matrix, which is -3, becomes +5. So that's 5. Okay. Now let's do this for here for the last variable, which is z. So for z, zd will be, so this one will be the same, so 2, 1, 1. The second one will also remain the same, 1, -1, 2, and then this time we'll change the third column, so and sub it with 1, 0, 3. Here 1, 0, 3. Okay, now I'm going to find the determinant here. To do that, I'm going to have to actually, you know what, I will use this portion to find the determinant, this column to find the determinant. So instead of 2, I'm going to replace that with 1, because ideally you always want to use the ones that have the most zeros, and from here this was the column that has at least it has 1 0. The other two columns, they don't have any zero, so we're going to use that. So 1 here. So then I'm going to use, if I'm going to use this one, then I'm going to use these two. So 1, 1, -1, 2, and then which will be -0, and I'm going to put 2, 1, 2, 1, 1, 2, plus 3, and these two, so 2, 1, 1, -1. Alright, so from here we get 1 times 2 is 2, 1 times -1 is -1, 2 minus -1 will become 3, and times that by 1 will be 3. Now this is 0, so it will just be 0. Here 2 times -1 is -2, 1 times 1 is 1, so -2 minus 1 will give me -3. Now there's a 3 outside, so which will make all that -9. Alright, so 3 take away negative 9 is negative 6. So therefore, Z, according to the Cramer rule, is that Z determinant divided by the quotient of the determinant. So minus 6 divided by minus 3, which is positive 2. Okay, so we have the values for all the three variables. X is minus 3, Y is 5, and Z is 2. Now it's always a good idea to try and check if your work is correct, because here it does involve some steps, and it's likely that it's possible one could make a mistake. So to be sure that you haven't made any mistake, so you can check it with all the equations here, with all these equations. So what I'm going to do is I'm going to sub each of these values in each of these guys and see if they are if we actually we get all these values. So for the first one, I have 2 minus 3 plus 5 plus 2. So what do I get here? So this is minus 6 plus 5 plus 2. So this becomes minus 1 plus 2 is 1. Alright, so that works with that. I'm going to try this with the second one. Minus 3 minus 5 and 4. So plus here 4 times 2 is 8. Well, you see that this is minus 8 plus 8, which is 0. Last one, minus 3, 2 here, so 2 times 5 is 10. I have here minus 2, so minus 2 times that is going to be 4. Sorry, minus 4. So minus 3 plus that plus 10 is 7. Take away 4, 3. So you see we get these values. We have 1, 0, 3. So therefore, these values are correct. Alright guys, thank you very much for watching, and I will see you in the next video. Have a good day. Bye bye.